Let's jump into this next one here. So I want to lay out the hypothesis testing approach. I'll make a little shout out to OpenStax here because they've got good material that I think is very useful. So this is my sort of broken down set of steps. There's actually nothing to do on this page, just kind of this is what I am going to walk you through. And the first couple of steps are the hypothesis creation. This can be a pretty confusing section. But again, but let me pull up this page here because I think this is actually really nice. Where the heck was that? Well, I'll just show you how to get there. OpenStax, statistics, chapter 9, I think. Let's go back to the contents. Hypothesis testing. Yeah, here we go. So I think if you're looking for additional material to read about hypothesis testing, I think this is a really great kind of starting point. But I like their example here about, people claiming things, and then what a statistician would do is go out and they would test those claims. And so what we're doing is we're practicing the process of hypothesis testing, which is built on the back of, the normal distributions and margin of error and confidence intervals and all of that stuff. Okay, so let's get down to the nitty gritty here. And I've got 3 examples. So your job on this sheet is just to say, what is the null hypothesis? What's the alternate hypothesis? The key here is, and I've got these included here because these can be hard to make on Excel. You can jump in here and copy the symbol and then paste it in. But the key here is that this first part of this sentence here, the H naught always has a symbol with equals in it. So that means that this symbol, or literally this symbol would be in the null hypothesis. I call it the null hypothesis because it has the 0 in it, which is the subscript. H0 really should be a subscript. I think it's, I didn't get that looking very good in Excel. I don't know if there is a subscript function here. Yeah. So anyways, when I make this, what I'm going to do is I'm going to read what it says, and then I'm going to write 2 statements that cover the entire spectrum. So for instance, if I say X is greater than 30, then I can translate that as X greater than 30. The other side of that would be X is less than or equal to 30. These would be my 2 things. And then because this is the one that has the equal sign in it, this is the one I assign to be the null hypothesis. So then I would say my H naught is X is less than or equal to 30. And my HA is X is greater than 30. So that's how I recommend doing it. Writing the 2 statements, not worrying about which one is null and alternate at the beginning, just trying to do a real fair translation of the words into symbols, and then you're putting them in the right place based on which one has the equal sign. And in fact, this is exactly the end result for this first example I'll do for you. No more than 30%. No more than 30%. So P is less than or equal to 30%. I can put percent there if I want. And then that means that the other side is P is greater than 30%. And these then are exactly in the right order because the one with the equal sign should be the null hypothesis. I did pull these examples from OpenStax. So if you want to confirm your answers before you move on, you can circle around and look at those as a way to get support. I might have changed a word or something here, but the actual examples are straight out of OpenStax, and so you can check your answers there. So that's the key, right? So if I say something like, and we'll go back to OpenStax here for a second, this car dealer, its new small truck gets 35 miles per gallon. The car dealer says the car gets 30 miles per gallon, right? Then I could say, well, that means that the mileage equals 30, and the other side of that would be the mileage, and this is where I'm going to use this symbol, is not equal to 30. And so again, once I've written, so this is my m equals 30 to cover the whole spectrum of everything. I need to say m is not equal to 30, which really includes two things. It's the m is less than 30 and the m is greater than 30. And so if I look at this, I say, okay, well, then this has to be the null hypothesis because it has the equal sign in it. This one is going to be my alternate hypothesis because it doesn't have the equal sign in it. So this, that's how I approach writing the null and alternate hypotheses. All right. Hope that helps. And then we're going to actually move into hypothesis testing next, which, well, this is just been a short video. So let's just pause here and okay, so picking up on the next sheet, I've got a paragraph here, then we've got some other words here. Let's just start with this and do a little bit of practice with what we just said. So suppose a baker claims his bread height is more than 15 centimeters. So h greater than 15. The opposite of that, to cover the whole spectrum, would be h is less than or equal to 15. And so there is my two hypotheses. The one with the equal sign in is going to be the null hypothesis. So Q1, state the null and alternate hypotheses. I can do that right where I had this, but I'll just kind of reformat it over here just because it typically goes in this order. So this is going to be the one that I put for my null hypothesis. This is going to be the one I put for my alternate hypothesis. So again, I took these words. He claims his bread height is more than 15 centimeters. And so we ended up doing this, and we ended up making that the alternate hypothesis because it didn't have the equal sign in it. So the other side becomes the null hypothesis. All right, so now we're going to start getting into the actual test, but there is an important detail here about the significance level. And this is really about the strangeness. Like, remember back in the intuitive approach, we had like a 2.3% chance, a 2.8% chance of getting 60 flips. And you had to decide, like, is that weird enough or not? So when we do science, we don't have to kind of go with our gut about whether it's weird or not. We set standards ahead of time. So a very common significance level is 0.05. That means 5% chance. So if it's something that's less than 5% chance, is really unlikely to happen. And then it passes our test. And so we are able to move forward and make a conclusion that says, well, this is too weird for us to accept that what we started with as our null hypothesis is what we're going to end up agreeing to. So here's the actual information about doing this test, that 10 loaves of bread. So he's trying to prove to this crowd of people that he is right. And so 10 loaves of bread, mean height of the samples is 17. That's a really good sign because 17 is bigger than 15. And so we're ready to go into the actual calculation. Now, the z-score is essentially the thing that we're going to use in order to get to the probability. We've done a lot of practice with that. The z-score formula is a little more complicated than the standard formula. And so we just kind of walk through these pieces here. We're going to take the sample mean, that's 17, minus the null hypothesis mean, so that was 15. And the null hypothesis, remember, has an equal in it, so it's always going to have an equals that we can compare to. And then we're going to divide by, I'm going to use parentheses again because there's a division here, and I want to make sure this gets divided correctly. The population standard deviation, which is 0.5, that comes from the original paragraph, over the square root of the size of the sample, which is 10. And this should give us our z-score. So this is our z-test score, right? X-test, z-test. Now, if you're kind of tracking z-scores and you're making sense of this, 12 is a really, really high z-score. And so we should feel very comfortable with the fact that this is a really odd result, because that is going to turn into a very, very small number. 1 minus norm dot dist, and we're putting in norm dot s dot dist, and we're putting in our z-score and saying true, and we're going to get, basically, there's, I don't know how many zeros we'd have to get an actual result here. Oh my God, that's a lot. That's very small. So basically 0 is the answer to that question, which is, what's the chance of the average being higher, that number or higher? 0%. That means that if 15 really was the average height, and he just did a sample and got 17, it's like, is 15 really that seems so weird that I'm going to reject the null hypothesis, which was, now I want to try to say this in words. So we reject the idea that the heights of the bread are 15 centimeters or less. Based on our results, there is a 0% chance of getting the sample mean we obtained, which was 17 centimeters, if that null hypothesis is true. So it's a really, really, really tiny probability. It's so tiny we can't even measure it. And so I'm trying to say something about what we can conclude. One of the things that's hard is that there's really only 2 options here. And sometimes students, well, most of the time, I think students think the opposite of reject would be to accept it. But the opposite is not acceptance, it's failure to reject. So your 2 options at the end of hypothesis testing are reject the null hypothesis or fail to reject the null hypothesis. We don't necessarily accept it because we didn't prove that that's right. We just didn't disprove that it's right. We didn't prove that it's wrong. And so therefore we're just letting it sit there. That feels kind of like, why are we being so hesitant? But that we didn't set out to prove it. We set out to disprove it. And so therefore, if we don't, that's what we're going to say. We fail to reject the null hypothesis. Okay, I'm going to do one more video on the two-tail situation, and then you're going to do a little bit of practice here. And again, those 2 practice problems are covered in OpenStack, so you're welcome to use that as a support, and I'll see you in the next video.